Hey everybody, this is Larry. This is day 16 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. Seems like there's some issues with the daily challenge, as I can see on the front page. Hopefully not for me, but we'll see. Yeah, I mean, it looks like it's still a premium problem, but lucky for us, or for me anyway, I have premium. Have I solved this one before? I have solved this one before though, so I don't know what that means. What was I going to say? Yeah, today I ran like 6, 7 miles, or I ran 7 miles exactly, but so, like it's only a subset of it really hard. So we'll see how that goes. 70 days till marathon. Yeah, maybe I should do a separate vlog channel, but it's fine. I don't. I barely have energy to run it, let alone doing even more. But yeah, let's see. 624 maximum distance in arrays. You give an M arrays which is sorted in ascending order. Okay. You can pick two integers from two different arrays and calculate the distance. We define the distance between two integers a and b to be the absolute difference, a and b. Okay, I mean, I think this is kind of interesting, right? So there are a couple of things we can think about initially. I mean, we can look at the constraints, but you know, we can reduce this one step at a time is what I mean, right? For example, if you're trying to maximize the difference, well, what does that mean? That means that the middle numbers don't matter, right? Given an array, a lot of the middle numbers don't matter. Just because, well, if you're in the middle, you always just want the min and the max, right? At least within one array. Well, within two arrays, it's the same, except for you don't know which one's better, which is the max minus the min, or the other max minus the other min, right? And if you do it that way, for every pair of them, you get n squared. They use m here, so I guess it's more m. So m squared, right, or the number of arrays squared, because you know you could do and compare, and maybe it's m choose 2 if you want to say, but that's still m squared just over 2, which is still going to be too big for 10 over 5th, right? Well, the other thing is that, well, it doesn't even matter, right? Is basically the maximum. I think one thing that I kind of spoke a little bit too quickly, and I was a little bit rough, is that for this particular one, you want two different arrays, so you can't just do the same array. If you are able to do the same array, then it doesn't even matter, right? Then the absolute difference is just going to be the smallest of the order arrays, which you can do a loop for. You don't even have to check the middle numbers, as I say, because it is in ascending order, and the max of whatever, right? So you could do that in one pass, and that's easy. This problem is actually good because I think this idea comes up a lot in maybe not a lot, but comes up like often enough. I want to say maybe a few times. I don't know. At least on Leetcode contests, where basically you're trying to find. I mean, basically what they're telling you, right, from two different arrays, and then the idea is that. Because I feel like we did this maybe like in the last month on a Q4. Not just this, because but this being a component of a Q4, right? And for a difficult or hard or a Q4, I often talk about how the hard part is that you need to solve basically 2 or 3 problems kind of in a way, or like articulate them in some combination to get to the answer, right? And this is one component that comes up here and there. Maybe not super often, maybe not common, but not super rare either, right? Is that you have this idea of, because I think there was like a tree problem that we did recently with rerouting. But yeah, it's just like getting the max that doesn't include itself or something like this. So the idea here is pretty straightforward. Right, is that there are only 2 cases, right? So let's say we take one particular row. I just actually put it here, so you can see. If we take one particular row, and let's say we're trying to get the min, right? So of everything that's not including this row, right? Then there are only 2 possibilities, right? Which is that the minimum. The global minimum is in this row, right? If the global minimum is in this row, then that means that this minimum is the global minimum, right? Which means that we need to find the second minimum, right? Hope that makes sense, because if the minimum for all the rows are here, then that means that the second minimum will be something that's not in this row, just by definition, right? Which is not in this row. The other possibility is that the global minimum is not in this row. Well, then you just already have your answer, right? Because then now you can just use the global minimum. So those are the two very simple case analysis that you can do with yourself, and that will allow you to get the answer. Okay, so let's get to it. And I don't like using M because it's just confusing, but I think for this one maybe we just keep it consistent a little bit, right? So then now we want two things, right? We want the min and the max, right? So we want maybe min 1 is equal to min 2 is equal to infinity. Max 1 is equal to max 2 is equal to negative infinity. We just choose some random big number, right? Well, I guess I choose the same big number, but yeah. And then now for just say I call it a row, but it's fine, right? For row in arrays, then the current min is going to be equal to row sub 0, and the current max is going to be row sub, the last element in the row, right? Okay. Yeah, and then now we just have to check if min 1 is less than the other way around. If min 1 is greater than the min, then now we want to update min 1, but we also want to update min 2 to be the current min, right? Because now it's kind of like we only have 2 elements, so maybe it's not as clear, but if you could think about it as like a 5-element thing, let's say you want to get the 5 minimum elements, then it's just about cascading everyone down to 1, right? Like the former first place is now second, the former second is now third, the former third is now fourth, and so forth, right? So then now, else if min 2 is greater than min, actually, I guess it could be equal to, because if it's equal to, it doesn't really matter, right? Yeah. And then now we just min 2. Oop. Right, so now we do the same for max. So if max 1 is less than max. And keeping in mind that for this particular problem, it doesn't have to be distinct, which is why the equal thing works. Because if you just have the same number, then min 1 will be equal to min 2, which is okay, right? Because that means that you have 2 versions of that number. Yeah. Okay, so max 1 is equal to max. Max 2 is equal to max 1, right? And I think one thing that I want to point out just more explicitly, like I think I kind of showed it, but maybe it happened too fast, almost like a magician's trick, is that I think because one thing that I always worry about is that people always think about how, or they ask me questions in a way that are like, they're like, okay, why do you do it this way? Is it because you memorize these patterns? And the answer is no. Like I don't like I have this general idea, sure, but like I don't think about, or I don't memorize the greater than equal to signs and stuff like this. But what I do is that I just give it a quick think of, okay, well, if they're equal, what happens? And then I just write it out. Right, and sometimes it's wrong, right? Like if you watch this channel enough, you see that I make a lot of mistakes. But yeah. Yeah, so that's basically the idea. Now you end with min 1 and min 2, or max 1 and max 2. There are actually a couple of ways you can do this, right? I mean, I think there are definitely ways you can do this. I think for me, there are two obvious ways to do it. I'm just a little bit lazy to figure out which one. One is just for, you could just do it again, right? This is one way. It's not necessarily the best way, but it is easy to write because we already have written most of it, right? Is that, oh, maybe best, we want to minimize, so we'll just set it as, is go to min, best, so yeah, so we have if min is not equal to min 1, right? Then we can just do this, which is the max minus min 1, right? If max is not equal to max 1, then we can also just do max 1 minus the current min. And that should be good, right? Because it's just taking one of these. Oh, I think I forgot to use the min too, right? So then if it is, and maybe I'll just rewrite this a little bit because I don't like this double negative thing. But yeah, if it's equal to min 1, then we want this to minus min 2, right? Same idea here is that if we have this, then we want, yeah, this is a little bit whatever, but should be fine. Hopefully. Well, getting negative answer means that something's wrong. Did I get something a little bit awkward? I mean, clearly, but definitely should not have a negative 1. Oh, I guess that doesn't make sense though. I mean, I guess min 2 could be infinity if we're not careful, so definitely need to check about that. Though m is 2, so maybe that can't happen. Because you can, oh yeah, there should never be infinity or negative infinity or whatever. But I guess if you have 3 minus 4 is what, yeah, okay, but okay, yeah, I guess 3 minus 4 is negative 1 and is how this comes into play. But we can just, we could just add absolute value. I mean, the absolute value is just being a little bit lazy, to be honest, because if it's negative, it just cannot happen, or it's not the min, right? Well, it could be the min, but no, it's just by definition cannot be the min, because if it's 3 and 4, that means that you just, by a very simple argument, that you can even change the 4 to 5 and it's already bigger. But I just kind of, it's either adding absolute value or adding an if statement that if max is greater than min 2 or whatever. I don't know. It's a little bit involved, so I don't know. Did I misread this? Oh, maximum distance. I messed this up. Okay, so that's fine. I mean, okay. I mean, I think the idea is still the same. It's just that, we do this thing. So, okay. Relatively straightforward. I didn't misread that one, though. Do I still need the absolute value in this case? I don't think so, because we're trying to maximize now. And I don't think that affects it. Give it a quick submit. Hopefully I didn't make a mistake. Last time I didn't, so yeah. 1599 day streak, yay. So okay, so this is one way to do it, right? I want to do another way as well. This is linear time, constant space. Hopefully it is straightforward. We do 2 pass. But yeah, and it's not so, it's usually, if this is a component of another Q4, it doesn't really matter in the sense that, this is linear already, so this is not any worse. But you can actually optimize this a little bit better by keeping track of the indexes of the mins. So, okay, so let's say, and this is just slightly faster, but more complex, right? Now, it turns out that I misread the problem, but But maximizing and minimizing is the same idea. And well, no, that's not true. Huh? Minimizing would be way different because you just try to, yeah. I don't know why I thought it was max. Well, I mean, I thought it was min because that doesn't make sense at all. Huh. It's just that I implemented, but then at some point my head flipped a weird switch or something. But in any case, yeah, the idea here is just keeping track of an index, right? Yeah, I mean, you're even going none, it doesn't really matter. I don't even know if these variable names are probably terrible, honestly. But yeah, the idea here is just keeping track of the index, right? So if this is then min 1 index is equal to index, min 2 index is equal to min 1 index, right? So the same idea as before, right? It's just that you're keeping track of index a little bit. Right, and then now I don't know why I put this up. It's fine. And then the idea is that now you can just look at the max numbers, right? So if max one index is not equal to the min 1 index, then you can actually just return it. But I'll write it out just because sometimes I don't want to think about I don't know, right? I don't want to think about possible edge cases on a contest, for example, but I think this makes sense, right? And then in a not double negative kind of way, if they're the same, then what do we do, right? If they're the same, then we can just take max 1 minus min 2. Yeah, we take the max of this, or max 2 minus min 1, right? Guess we don't need this, fine. And I think that should be good. Hopefully I didn't miss a case in my head. Yeah. As you can see, I mean, complexity-wise, this didn't change, right? This is just why I usually don't worry about it unless it's some, I don't know, it's just very close for whatever reason. But this is O of n, and of course this makes it easier because it's just, we made it about twice as fast. Yeah, maybe not really, but right with this loop instead. But you know, and obviously it's not actually twice as fast, but at least in their measurement, there are other things that goes into it. But 1 pass instead of 2 pass, it is faster by some percentage. But yeah. Usually I don't worry about it unless there is something very particular. And what was I going to say? Yeah, and for this particular one, it is easy to make this thing, but for certain problems, this may be a harder thing to generalize a little bit, right? Because this relies on knowing how to handle the max in this way, where the other one is by component, so you can loop over the component. It's just harder to get wrong. That's all I have for this one. Let's take a look at what I did last year. Okay, well, last year I was lazier. Why did I write it this? I mean, I know I wrote it this way, but I mean, this is just the same. Was I just lazy? Was this a contest problem or something? Why did I do it this way? Because this is just very lazy. It doesn't seem like a recent contest. But yeah, and even this, you can just use a sorted list, which is faster than insort. But in any case, no, I see what I did. I think someone did teach me this, and I keep forgetting to do it. I didn't write it out, but this is like another way to think about this, even though not exactly, is just using a heap of 2 elements, right? And that's basically what this is doing, or this is what this is doing. You can think about it as using a heap of 2 elements for min and max, and then just doing the same logic that we did. This is exactly the same code that we have here. So yeah, just way more confusing to look at, but not incorrect. I was gonna say sorted list, but I missed the if it's greater than 2 part. So that what this does is that it keeps it as 2 elements, which is pretty precise because this, even though this looks really awkward, it's just 2 elements. Like I said, you could treat it as a heap of 2 elements, and that is just the constants, everything don't matter for 2 elements. So yeah, okay. Past Larry is a little bit more clever, but I feel like this is more straightforward to explain. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.